All right, this is video number 3 on worksheet 10.2. On the first video, we looked at volume to volume stoichiometry problems. In the second video, we did the mass to volume. We looked at two different ones. One that was at STP, where we started with a mass and we converted it into a volume, and then one that was not at STP. These questions that we're going to go through in video number 3 are going to be very, very, very similar, except the only difference being that they're pretty much the opposite path. So again, the last video we started here and we kind of worked our way down to here. We looked at one situation that was at STP and then one that was not at STP. And then that was kind of down this way. On this video, we're going to start with a volume, right? These questions are all going to start with a volume. If you're at STP, you can just use that 1 mole is 22.4 liters, and then you go to moles, and then to moles using those coefficients, and then finally use a molar mass calculation. And so that reached a 3-step Stoich problem. And then if it's not STP, we have to start with a PV nRT equation, and then that will solve for moles there, and then it's just a 1-2-step Stoich problem. So anyways, we'll show you the easier one first. That's the one that's going to take place at STP. And so what we'll look at here with the volume to mass questions, we'll go ahead and fill out our conversion pathway first. So we're going to start with volume of A. Volume of A is going to be turned into moles of A into moles of B, and then finally moles of B into mass of B. We're actually going to skip number 1 for a moment. We'll come back to that one after we do question number 2. So we'll do question number 2 first. This is going to be the one that's at STP. It's going to be a little bit easier of the ones. And so in this question, it says 75 liters of C2H2 are reacted at STP, standard temperature and pressure. How many grams of H2O can be made? So again, we're starting with some amount of volume of the C2H2. Right, and then we're going to figure out how many grams of water should we predict that we can make at the end. And so let's do it. We got 75.0 liters of C2H2. This is going to be a 3-step stoichiometry problem. Because we are at STP, we can use that shortcut. 22.4 liters is equal to 1 mole of gas. In this case, we're talking about liters of C2H2. And then moles of C2H2. By the way, this is called ethine. C2H6 is ethane. C2H4 is ethene. This is going to be C2H2. It's going to look like this. You got a triple bond, and then a hydrogen, and a hydrogen. So C2H2 is ethine. Y-N-E. Ethine. So we've got 1 mole of C2H2. We're going to do our mole conversions between C2H2, and in this question, it's asking about moles of water. So I got to look up here for my stoichiometric relationships. There's a 2 in front of the C2H2. Looks like there's a 2 in front of water. So we're just going to plug in. It's a 2-to-2 mole ratio. One last step, as you probably have memorized at this point in time, 1 mole of water is 18.02 grams of water. Maybe you memorized that, maybe you haven't. But it's a common one, so a lot of us have probably had that stuck somewhere in our brain at this point in time. So in our calculators, we're going to take 75 divided by that 22.4 times 2 divided by 2, or you could skip that step because you're just going to end up with the same number, and then you're going to multiply by the 18.02. So if I did that right, 75 divided by 22.4 times 2 divided by 2, and then times the 18.02, I got 60.3. And so 60.3. The units are going to be grams of H2O, or grams of water. Go ahead and circle or draw a square around that answer. Go ahead and do that. And we got 60.3 grams of water. Let me clean this up by canceling a couple units here. We got liters divided by liters of C2H2, moles divided by moles of C2H2, moles of water divided by moles of water. So everything works out. This is going to be an example of when we're starting with a volume and we need to convert into grams. again, at standard temperature and pressure. So let's look at the next case. I'm going to clear up some space here. If we're not at STP, this is going to be just like what we did on worksheet 10.1. We have to do a PV and RT equation first. So because we're not at STP, we're going to go from volume and we're going to solve for moles with a rearranged PV and RT equation. After that, we can do a two-step stoichiometry problem. So as I always recommend, let's go ahead and label what we've got when we annotate our question. We've got 8.7 liters. That's going to be volume. 50 degrees Celsius is temperature. One thing you know at this moment in time is I can't keep it at 50 degrees Celsius. I got to add 273 to that. So 50 degrees Celsius plus 273, we'll convert that into Kelvin. That's 323 Kelvin. Oh, wow. And then we've got 200 kPa, and what you know about kPa is I can't keep it as kPa. It's got to be in atmospheres. So we have 200.0 kPa. That is 101.3 kPa equal to 1 atmosphere, or 1.00 atmospheres. So 200 divided by 101.3, 1.97 atmospheres. Right, and that's going to be the pressure. And so what we've got is volume, temperature, and pressure. What we're going to solve for is the last variable, which is moles. So we've got PV equals nRT. In this case, we're going to isolate moles by themselves, right, because that's what we want to solve for. Divide both sides by that R and T. I kind of clean this up a little bit, and all that stuff on the right side will cancel. So we have N equal to PV equals RT. So I'll go ahead and rewrite that down here. N is equal to PV, pressure times volume, over R, which is our gas constant, times temperature. So pressure. Let's plug everything in. Pressure was 200 kPa, but now it's 1.97 atmospheres, 1.97 ATM. We're going to multiply by the volume. It looks like is 8.75 liters. R values are that 0.0821, and that is ATM times liters over moles times Kelvin. And then temperature, we calculated was 50 degrees Celsius, but we need that in Kelvin, so 323 Kelvin. Quick just order of operations, PEMDAS thing here. Make sure the bottom of that fraction is in parentheses or you'll get the wrong number. So we do want to multiply all of those things together before we take the stuff on top and divide. So 1.97, here we go. 1.97 times 8.75 divided by, start parentheses, 0.0821 times 323. And it looks like I got 0.6500. So 650, this is going to be moles. Let's cancel some stuff out here. Atmospheres divided by atmospheres, liters divided by liters, Kelvin divided by Kelvin. And what we're left with is 1 over moles, which is going to turn into moles. What we're dealing with here is 8.75 liters of, I guess I should say, water, right? That was given there, 8.75 liters of water. So this can be moles of water. And at this point in time, I'm going to steal that. I'm going to go ahead and draw my fence and rail right off of that, because I know that I need, at this point, we've gone from volume using that PV and RT. Now I've solved for moles. I just have two steps. I'm going to go from moles to moles and then moles to mass. So 2 steps left, just a fence and a rail question. 0.650 moles of water. We've got moles of water on the bottom. In this case, we're going to go to moles of carbon dioxide on top. And I got to look at my ratios. Looks like there's a 4 in front of the carbon dioxide and 2 in front of the water. And one last step. We want to figure out what mass of carbon dioxide was made. So 1 mole of CO2. And then if you look up on your periodic table, carbon is 12.01. Each of the oxygens is 16. So 12.01 plus 16 plus 16. Again, this is one we use frequently, so you might have memorized at this point. 44.01 grams is what carbon dioxide weighs. Maybe you know that, maybe you don't. And so again, we've got 0.650, 0.650. We're going to times 4 divided by 2 times 44.01. Got 57.2, so 3 sig figs, 57.2, and I'll clean everything up. Moles divided by moles of water, moles of CO2 divided by moles of CO2. My units are going to be grams of CO2. So again, those are going to be the type of questions that we're going to have here for volume into mass of another thing. So in this question, we did just a 3-step stoichiometry problem when it was at STP, and then we did a PV and RT question, and then we had to do a stoichiometry problem. We had to do that in this case because, again, this one was not at STP. It gave us a pressure, it gave us a temperature, those not being at standard temperature or standard pressure, which is what STP is. So those are 2 examples. Again, with the videos that we've provided, you should be able to do the rest of the worksheet. I know these are challenging questions, but I know you guys can do them. If you look at the next page, these are general problems. All that means is it's going to be a mix of a bunch of different things. Those could be, volume to volume questions. Those could be, volume to moles to mass, right? Kind of like the question we just did. And then on the last video would be kind of the opposite of that, would be just mass to moles to volume. Okay, so it's just a bunch of different types of problems, but it's all going to be, these general problems are all going to be questions that you've seen on this worksheet already. Some of them, again, are at STP, some of them are not at STP, like this one down here. Quick reminders, everything does have to be in atmospheres because of our R value that we use is in atmospheres. And then everything does have to be in liters, and everything does have to be in Kelvin. So if you're given something else, you can look at that worksheet 9.1. That was our conversion worksheet. Worksheet 9.1 to kind of help you with some of those gas conversions or volume conversions if that trips you up. You can go back and look at worksheet 9.1. So that's going to wrap it up for these videos on worksheet 10.2. Hopefully that was helpful. Do your best, right? And I think you guys will find success with worksheet 10.2. Good luck.